Hello, I have a couple of problems from the second half of Chapter 2, Applications with Integers. I like this problem because it's an algebra problem that we don't really need algebra to solve. It's a little bit of tricky reading, but if we make a good picture, it'll be a piece of cake. So let's read it. Suppose the temperature outside a hot air balloon decreases 3 degrees Fahrenheit for every 500 feet the balloon increases in altitude. Find the change in temperature as a signed number, positive or negative, outside a balloon that decreases its altitude from 8,000 feet to 6,500 feet. That's a mouthful. Okay, what are they saying? The temperature decreases 3 degrees for every 500 feet the balloon goes up. Okay, but our balloon's not going up. Our balloon is going down. So we can think of it this way. When the balloon goes down 500 feet, down is negative, then the temperature is going to go up 3 degrees, okay? We can just switch those. Now this is what I mean about drawing a good picture. And when I say good, I mean not at all good. It just has to have the information, right? I love art, but mathematicians are not always artists. We're starting at 8,000 feet, and we're going to go down 500 feet, and we're going to go down 500 feet and down 500 feet until we get to 6,500, and each time we're going to add 3 degrees Fahrenheit. So let's start here, and we're going to go down to 7,500. When we did that, the temperature went up 3 degrees. Then we're going to go down 500 more to 7,000. And the temperature went up 3 degrees. And we're going to go down again 500 to 6,500. And we do that, it's going to go up 3 degrees. Okay? So what do we have here? We went down a total of 1,500 feet. You don't really need to know that. And the temperature went up a total of positive or plus 9 degrees Fahrenheit. What else do we have here? This is an average problem, and we know to find the average, we add up all the things and divide by how many there are. I included this problem because I actually had to read this problem 57 or 60 times before I got the correct number of men in there. There's 10 men in there, not 9. Read it carefully. In a weightlifting program, 2 men bench press 300 pounds, 3 men bench press 350 pounds, and 5 men bench press 400 pounds. What was the average number of pounds that these men bench press? So, take a look here. If you weren't paying attention, sometimes we do things without reading at all. We would have 300, 350, 400. Add them up and divide, right? No. There's not 3 men there. There's 10 men there. So we have 2 men that did 300 pounds. And we have 3 men that did 350. And we had 5 men that did 400. Okay? We need all of that on top. And how many men were there? Not 3, not 9, 10. Okay? So what does this all equal on the top? I'm going to bring it down here. We have 3,650 on the top. And we have 10 underneath. So remember, fraction means divide. And when we divide it, we get 365. What? Bananas? No. Pounds. Okay. Now, if it helps you to remember all these 10 different men bench pressing all these 10 different weights, it's okay to write 300 plus 300 plus 350, and you write out every single one. Okay? That's okay with me. Whichever way is going to help you get all the information in there is the way you should do it. I don't care. But I'm going to run out of room, so I'm going to abandon this method. But you probably write neater, and you would do just fine. Just remember to total up all your addition before you divide. Okay, introduction to like terms and polynomials. I think I told you before I love polynomials. It's still true. The thing that we need to remember for adding like terms is that we add apples to apples and oranges to oranges. All right? We have apples and oranges and bananas in this problem. Let's look here. This is what I'm calling the apples. We can only add things that have the same variable with the same exponent. We have some x squareds right here, and we have some x squareds right here. Then we're going to look at our x's. We only have one term with x's, so we're going to leave that by itself. And then lastly, we have some constants. That's a -8 there, and a +1. So those are the things we're going to add. What's 2 minus 3? So that's -1. That's how many x squareds we have. I'm going to leave that -1 there, but you don't have to. We are going to keep our plus 5x. We're going to leave that alone because there's nothing to add. And then at the end, our -8 plus 1 is going to become -7. Okay? Now we can evaluate these. The directions say evaluate for x equals -2. I'm going to go ahead and do that just because it's good practice for order of operations and those pesky negative numbers. Because look what we have here. We have to keep this negative out here. That's why I drew the 1 so that we would remember. Now we're going to put -2 in for the x, put it in parentheses so we can keep track of that pesky negative and keep that exponent up there. Okay? So let's do our exponent first. -2 times -2 is +4. But I do have this -1 out there that I need to keep. I can go ahead and do this 5 times -2 now. That's going to be -10. And then -7 comes down. -1 times 4 is going to become -4 plus -10. I'm going to change this right now to a plus -7. Some of you don't like that, but I do, and I'm in charge for this 3 minutes. I like to add them all up together as negatives, because what can I do? I can just see that they're all negative, so I'm going to have a negative answer. And then I can just add up 4 plus 10 plus 7 is 21. And that's it. Okay? That's not so bad. Lastly, we have some solving equations with integers, which means pesky negatives. But this is not that hard, and we've done this before. We just have some negative numbers now. The rules are the same. Keep everything balanced. Whatever you do on one side of the equal sign, you have to do on the other side of the equal sign. So what are we going to do to get rid of this plus 20, to get the n by itself? The only legal thing we can do is the opposite and do it to both sides. What's the opposite of plus 20? Minus 20. Minus 20. Keep the equal sign in the middle. These go away. -100 plus -20 is -120. What else do we have here? Oh, there's my n, sorry. Number 22, we have -9x equals -72. This is not that big of a deal. Just divide by -9. Remember, we're trying to get the x by itself. So we're not just dividing by 9, we're dividing by -9 to get the whole thing out of there. Divide by -9. Keep the equal sign in the center. These cancel. We have our x. -72 divided by -9 is +8. Okay? And at the bottom here, to get rid of the -3, the only legal way to do is the opposite to both sides. So we have +3 plus 3 These cancel, keep the equal sign in the middle. Negative 12 plus 3. We know the answer is going to be negative because the 12 is negative. And then we can subtract the absolute value if you want a reminder. 12 minus 3 is 9. X equals negative 9. Some of you like to ask me, is this true, is this true, is this true? That's the definition of a solution, is it true? Did we do it right? Let's look at number 28. Does negative 9 make the equation true? So let's put it in there. Negative 12 equals, we're going to put the negative 9 in right here. Is it true that negative 12 equals negative 9 plus negative 3? Yes, it is. So it's right. Thanks, guys. That was a lot for one video, but hopefully it was some helpful review. Let me know if you have any questions. Thank you.